All right, so once more, I welcome each and every one of you to this lesson this afternoon. Dawin Sichimba, I'm a fifth-year medical student at Copperbelt University. So we are looking at biostatistics, and this afternoon we're going to look at frequency tables.
Same link. Just click on the link.
Please, if you're saying something, can someone unmute themselves, please? Okay. So I was saying that this afternoon we want to look at frequency tables, and then from there we're going to proceed to look at measures of central tendency. All right. So those are the two topics that we're going to look at this afternoon. All right. So let me share the screen, and then we look at what we have to look at for today. Okay. So I guess it's this one. Are we able to see the screen? Are we able to see the screen? Okay, so we're looking at, sorry, I think we're supposed to look at, the first one that we should look at is what? Frequency tables, right? Yeah, frequency tables. Then we come to measures of central tendency. Okay. So now, so we want to look at frequency tables and data presentation. Remember, last time we looked at introduction to biostatistics, and from there we did define that biostatistics is a science that deals with one, the collection, two, the organization, three, the analysis, four, the presentation, and lastly, I mean the interpretation, and lastly the presentation of information, isn't it? So now remember there is the presentation part. So how do we present information? How do we present after analyzing? How do we want to present our information? So this is where that aspect comes in, where we look at frequency tables and other graphical presentation of data. All right. So now, when you look at a frequency table, one thing about a frequency table is that it is supposed to have a title, just like any other graph that you would want to use to present your information or to present your data. That table is supposed to have a title, and it is supposed to be labeled with the appropriate denominators. Okay. So what are the parts of that table that we want to look at? Okay. So the denominator should be indicated in the table or in the title. Okay. Now, most of the times you want to also present the percentages together with the reported row numbers. For example, if you say that in a particular class, okay, let's say in a class of 40 students, I mean of 100 students, all right, in a class of 100 students, let's say maybe 10 of them passed the test, then you're going to say 10% of those students in brackets, which is what? Which is 10 students, isn't it? So 10 of them, which is representing 10% of students, passed that particular test, all right? So you represent the raw number together with the percentage. Most of the times it is more helpful to present information in such a manner. Okay? So in a frequency table, you highlight major findings and do not describe the entire table. So the only thing, remember, let's look at data. When you look at data, it can either be descriptive or it can be in form of numbers. All right. So you can either just describe the data that you have, or you can give it in form of numbers. Now, the descriptive data that you have is what is called the qualitative data. Okay. So if you are able to describe, if it's some data that you can just describe, then it is called descriptive. I mean, it is called qualitative. But if it has numbers, if it is in form of numbers, it is in form of quantities, then it is called quantitative. So data can either be qualitative or quantitative. Okay. Now, whenever we want to represent, most of the times when you are representing quantitative data or information, we use frequency tables and other graphs in order for us to present our data. Okay, so like I mentioned this afternoon, we want to look at how to quantitatively present our information or our data. And in this case, we're looking at frequency tables. So we're saying that a frequency table should have a title. You can't just draw a frequency table without indicating anything, without indicating the title. All right. Now, other than that, the denominator should also be indicated. Then percentages should be reported with the raw numbers. Okay, like I gave an example. What exact number is that percentage representing? Okay. Then a frequency table. In a frequency table, you highlight major findings and do not describe the entire table. Okay. So there's no need of starting to write a lot of things. We shall look at later on some of the qualities or general qualities of these graphs that we're talking about. Okay. So let's move on. So this is an example of a frequency table. All right. So in this case, you can see that this is age by sex distribution, and it is in form of groups. Now, before I can even continue, let me mention that when you have this, especially when you're talking about frequency tables, you can either have group data, okay, group data, or it cannot be grouped and grouped. Okay. So, for example, in a case where you have, let's say, for example, you only have about maybe 5 students in a class. Okay, you only have 5 students in a class. Okay, or maybe let's say 5 ages. Okay, 5 ages. Let's say there are those that are aged 20 years old, those that are aged 21, 22, 23, and 24. Okay, so all the students in a class, they all have those ages, either of any of those ages. All right. So it is possible to say, okay, those that are aged 20 years old, they are 5. Those that are aged 21, they are so much. Those that are aged 22 are so much, and so on. But in a case where you have a wider range of ages, okay, let's say students are aged between, let's say between 18 and let's say, for example, and 40. All right. So you don't want to start listing a whole lot of ages and put the exact numbers of students that are aged that much. All right. So in such a case, to avoid so much work, okay, to make sure that it's not cumbersome for you to do, you make groups. Okay, you make groups. What in this case, like in this case, you have age groups. So for example, you have those that are aged between 15 and 19, those that are aged between 20 and 24, and those that are above 25. So in this case, it makes things easier for you because you can't start listing those that are aged 15, those that are aged 16, those that are aged 17, and so on, up to whatever age. It's not going to be so easy for you to do. So instead, in that case, you make groups. Okay, you make groups, and it's going to make your work easier. Okay, so in this case, let's look at this table that we have. We can see that those that are aged between 15 and 19, they are representing 10%. Now, what that is for the males. All right, the males are 10% of all those that are between 15 and 19 years old. And what exact number is that? So you can see that they are 11.8 of them. All right. Then those that are aged, the females that are aged between 15 and 19 are 12, representing 40. Okay. Sorry, the numbers are the ones that the percentages are the ones that are in the brackets. Then the exact numbers are the ones that are outside the bracket. So those are the males that are aged between 15 and 19 are 10, which is representing 11.8%. Then the females that are aged between 15 and 19 are 12, and they are representing 40%. Okay. and so on. Then you go to those that are aged between 20 and 24. You can see that males are 45, representing 52%. Then the females are 10, representing 32% of those that are between that age range. Okay, so like I mentioned earlier on, you make sure that you represent the percentages should be reported together with the raw numbers. Okay, so this is the raw number and this is the percentage. Okay, and you don't write a lot of things. You don't start describing. You only write the major findings on the table. Okay, so here you can see that there are only 3 columns and how many rows? There's the title. I mean the title. You've written the title there, and then you have the first row, the second row, the third row, the fourth row, and the fifth row. You don't write a lot of things. You don't start describing anything. Okay, so those are some of the things that you have to take note when you're looking at frequency table. Okay, so let's look at graphical presentation of data. Now, how do you represent data? So there are several ways of graphically representing data, and some of them include the scattergram, the line graph, histogram, bar graph, and the pie chart. Okay, so let's look at each one of them in a bit more details. So now, okay, let's look at this diagram which I added to your PowerPoint. Remember, I'm using Professor Siziya's PowerPoint, so I'm going to use. I just added something to this PowerPoint. Okay, so let's look at the line graph. We'll start with the line graph. Okay. Now, first of all, before we even look at the line graph itself, we should know that graphical representation is a way of analyzing numerical data. Okay. So, like I mentioned, we have data can either be descriptive or numerical. Okay. Descriptive is where you're just able to describe. For example, if you're describing students, you say these students were tall, were short, were light in complexion, and so on and so forth. All right. But when you're talking about numerical data, you give the exact number, how many students were there, how many students belong to such a group, and so on. All right. So now, we're saying that graphical representation is a way of analyzing numerical data. It exhibits the relation between data, ideas, information, and concepts in a diagram. Okay. So in here, you have both data, you have ideas, you have information, and concepts just in a diagram. Okay. Now, it is easy to understand, and it is one of the most important learning strategies. So you find that one of the best qualities of a graph is that it is easy to understand even by a layman. Okay, even someone that has not really done so much mathematics, is not so much a specialist in that particular field, they can easily understand what you're trying to talk about in that particular graph that you've written. So it doesn't have to be so complicated. Okay, so it always depends on the type of information and in a particular of information in a particular domain. So there are different types of graphs, graphical representations of data, and some of them are what we have on this diagram. Okay, so let's start with the line graph. Okay, so line graph, or which is also called a linear graph, because linear line, one and the same thing. Okay, so the line graph is used to display the continuous data and is useful for predicting future events. So for example, I don't know how many of you have seen, since we are in the medical field, let me give an example in the medical field. I'm sure we've all seen an under 5 clinic card before, isn't it? So when you look at the under 5 clinic card, there's that part where there's a graph, okay, where there are those lines showing the growth, okay, showing the growth of the child. All right. Now, when you look at that part, you can see that the line can either be going up, or it can be going almost horizontal, or it can be going down. Okay. So when you take the child to the clinic or to the hospital, the child is sick for whatever reasons, then what happens is that the clinician or the doctor there is going to get that under 5 clinic card, and is going to observe the line, how it was moving in order to see the growth curve. It's called the growth curve, okay? So the doctor is going to look at the growth curve of the child and is able to predict and tell that at this particular time of the growth of the child probably was sick, or maybe was not eating well, and so on and so forth, okay? Well, if the child is not yet above 5, let's say the child is maybe, let's say 3 years old. So if the graph is going down, then you are able to predict that in the next 2 months or maybe 3 months or so, the child is going to be, the growth of the child is going to be stunted, or it is going to be going down, okay? Or if the line is going up, you are still able to tell that, you are still able to predict that, okay, at this point, this is what is going to happen. Another example is when you look at the current COVID-19 pandemic, okay? So let's say, for example, it's Monday, since they give daily reports, right? So let's say it's Monday, they report that, okay, we had, let's say, 50 cases. On a Tuesday, they report that we have, let's say, 70 cases. The next day, which is Wednesday, they report that we have, let's say, maybe 86 cases. On a Wednesday, they report, on a Thursday, they report that we have maybe 101 cases. So if you use a line graph to represent that information, then what is going to happen is that you'll be able to see that it's increasing, okay? It's more like the cases are increasing on a daily basis. And you are able to predict that maybe in the next 2 weeks, you're going to have so many cases on a day, on each day, okay? And accumulatively, we're going to have so many cases. So that's how a line graph is. It enables you to predict future events. Okay, so let's look at bar graphs. Okay, so this is the bar graph. So you can see that. Make sure that you know the difference between the bar graph and the histogram. Okay, so now when you look at a bar graph is used to display the category of data, and it compares the data using solid bars to represent the quantities. Okay, so we are using these solid bars to compare the quantities. So you can compare this quantity, let's say quantity A and quantity B, you can compare them. Okay, so you are using those solid bars. Then when you look at the histogram, okay, so the histogram usually it uses time. You are looking at time, okay, over a time frame. That's why when you look at the first part there, histo, we're talking about time, okay. So the histograms, okay, are the graphs that uses bars to represent the frequency of numerical data that are organized in 2 intervals. Since all intervals are equal and continuous, all the bars have the same width. So you can see that all these bars have the same width. By the way, one thing that we should understand is that when you look at the bar graph, okay, the width of each bar represents the frequency, okay. The area of the bar, okay, of these are more like rectangles. The area under these are representing more like the frequency, okay. Then let's look at the pie chart, okay. So the pie chart is also called the circle graph. So it shows the relationships of the parts of the whole, okay. So this is the whole, and then it is showing the parts of this entire group of data, and then it has parts, okay. So let's say, for example, in a class, there are those that got maybe, let's say 40%, those that got 45%, and those that got 50%, 60%, and so on. So how many got let's say 40%, okay, and then you represent them. So the angle, the size of the sector, okay, the size of the sector, when you are looking at a circle graph, the size of the sector represents the frequency, okay. The size of the sector, remember these are sectors, right? So the size of the sector represents the frequency. Or probably you can say that the size of the angle of each sector, okay, that is subtending each sector is equivalent to the frequency. So the larger the angle, let's say, for example, like this case, this is 45%, okay? So, and we have a larger angle there. So you can see that this is the one which has the highest frequency, followed by this one, and so on and so forth. So the larger the sector, the higher the frequency. Okay. Then let's look at this line plot. Now, when you look at the line plot, okay, in this case, the data is not continuous. Okay, the data is not continuous in this case. All right. So the data is organized from the least value to the greatest value. Okay. So let's look at what we have. So like I mentioned, we have the histogram. So the area and the area of the bar corresponds to the frequency. Then the bar graph, the height of the bar corresponds to the frequency. Okay. So bar graph, I think let me just give a recap there. For the bar graph, the height, okay, the height of the bar represents the frequency. But when you look at the histogram, the area of each bar represents the frequency. So here we're talking about the height, here we're talking about the area. Okay. Then the pie chart, like I already mentioned, when you look at the pie chart, the largest sector corresponds the highest frequency. So the larger the sector, the higher the frequency. Then let's look at when you look at the line graph. Okay, so this is the line graph. So look at what I was trying to talk about. So the line graph is enables you to predict future events. So you can see at this point it was almost horizontal, and then it starts declining. So at this particular point here, okay, let me try to use some sort of a pointer. To have something like a pointer. Okay, I hope you're able to see what I'm trying to talk about. So you can see that this is incidence of tuberculosis per 100,000 people in Sri Lanka. So between 1966 and 1970, okay, somewhere there, we can see that it was almost constant. The numbers of the incidence of TB was almost constant. Okay, it was a horizontal line. But after 1970, you can see that it starts declining. So if you are, let's say somewhere 1971, okay, 1971 somewhere there, you see that the numbers of the incidence of TB has declined. You can probably predict that in 1972, you're also going to have a lower incidence of TB. Then it starts increasing again. So it enables you to predict future events like I mentioned. Okay, so look at this. You can see that here you more like have groups. Okay, so you have it's grouped in groups of 10. Okay, so you have 10, 20, 30, 40, 50, 60. Now you see that in this case the line is at least it's looking more presentable. But look at the other graph here. All right, the other graph here, it looks a bit more scattered and it's quite scruffy, even though it's representing the actual data that we have. But there's a correct way of representing data using this particular graph and the wrong way of doing it. Okay, so make sure that you most of the times it's more imperative and it's more important to make groups like that instead of writing the exact numbers. Okay, so this is also a line graph which is showing the prevalence rates of Plasmodium falciparum in 8 locations. So there are 8 locations. Each color of these lines is representing a location. Okay, so for example, red is representing area 1, yellow is representing area 2, and so on. All right, so you can see that you can tell the difference. For example, this one, which is this is, I don't know if this is pink or purple. Okay, so you can see that it's increasing. Okay, with age. Okay, so the incidence of malaria in this case increases with age up to about 1 year, 1 year old. Okay, then it also increases, and then after the age of 5, it starts declining in this particular area, which is area 6. Okay, so that's why you find that when you talk of malaria, we can see that the people that are at risk, the population at risk, are those that are under 5 years. Okay, so this one is under 5 years old. They are at risk in this particular area. Okay. All right. So now, in conclusion, we should understand that we do not need to crowd these graphs. So simple graphs or tables convey messages much more easily. Okay. So let me try to also give some general overviews, or rather general rules about these graphs and tables. So a table or a graph should have a suitable title. So make sure that that the appropriate title is given to the graph, which indicates the subject of the presentation. Okay, I think I already mentioned that. Then the measurement unit. So for example, look at this, the graphs that we had. So here we can see that there is the measurement unit, which is in years. Then here it's in percentages. So make sure that you always have the measurement units. Then make sure that there's a proper scale. Okay, there's a proper scale. So you can see what made a difference between this graph here, okay, the first graph, and the second graph is that the first graph, this graph, which is correct, has a proper scale. Okay, it has a proper scale, and you can see that it is there are those scales from 0 to 10, 10 to 20, and so on. But in this case, there's no proper scale. Okay, so always ensure that there's a proper scale. Then the index. So the index the appropriate colors, shades, lines, design, and so on. So you can see that in this case, especially in a case where you are representing multiple data, okay, make sure that there's that index, like in this case. So red is representing area 1, yellow is representing area 2, and so on and so forth. So make sure that there's always an index. Okay. Then source of the source of data. Okay, so include the source of information where it is necessary at the bottom of the graph. Okay, is there any graph here that has a source of information or data that we have? Okay, anyway, so always make sure that you indicate the source of information. So this information, these things that we're talking about are very important when you're doing research. Okay. Then always keep it simple. I already mentioned that. Keep it simple. Construct a graph in an easy way that everyone can understand. I already mentioned that even a layman should be able to understand. Even someone that is not a specialist, who's not an expert in that field, they should be able to understand. Then it should be neat. Okay, it is supposed to be neat. This one you can even tell this graph and the previous graph. Obviously, this one is neater than this one. So always make sure that your graph is neat. It conveys the message much more easily. Okay. So thank you so much. I think this is the end of this lesson on frequency tables and data presentation. I don't know if there's any question on this part. If there are any questions, please you can unmute yourself and ask the question. So we are remaining with about 4 minutes to end this session, because it's always just about 40 minutes. Okay, any question or any contribution? In case there's something that you'd want to add to what I've already mentioned, please make sure you add. Anyone?